Hi, my name is Anjali Kantharuban, and today I'm going to introduce a technique which improves the performance of machine translation on languages without a lot of training data. Before we get into the new technique, let's review what machine translation is. Traditional machine translation involves an encoder-decoder model, which takes in sentences in one language, produces a vector representation of their contents, and uses that to output a sentence in another language. Fundamentally, this model, like all models, is a big equation with parameters that we are trying to figure out during training. We figure out what parameters are best by fitting the equation to the training data as well as we can. The problem here comes with rare words. Because we're trying to fit to the data, the model naturally focuses on being more accurate on words it sees more often. For high resource languages like English, this isn't a problem because even rare words appear many times in the training data. However, for low resource languages or languages without a lot of available data, rare words may only be seen once or twice, leading to poor recall. This has been addressed in part using a lexical translation mechanism. This mechanism allows the model to sidestep needing to recall every word it's ever seen by supplementing the model with a lexicon, or word-level translation table. The model in this case instead focuses on translating common words and figuring out where rare words would appear in the output based on context clues. A practical example of this is here. Let's say you see saffron once in the training data, and you also see more common sentences like I bought some salt. During evaluation, you might see I bought some saffron. The model translates the first part of the sentence confidently and then uses context clues to understand that the translation of saffron would probably appear at the end of the output. When the time comes, the model pulls from the lexicon to get the translation for saffron and slots it into place. But where do these lexicons come from? There are three types of popular lexicons: manual, statistical, or logical. Each have their weaknesses. Manual lexicons are expensive to produce. Statistical lexicons require a lot of training data, and logical lexicons miss a lot of alignment cases. Ultimately, none of them properly address the case where there are words only seen once in the training data. As an alternative, I propose the lexical alignment model. This is a neural network which generates alignments from sentence pairs to produce a lexicon for translation models. The model is trained with random words masked out to prepare it to align sentences with words it's never seen before. The extracted representations are based on the word and the context around it, so if the model is used to seeing a word aligned with another word, it'll use the context less in its representation. Otherwise, it'll use the context more heavily. We then calculate the cross-similarity for each word in the sentence to get sentence-level alignments. These alignments are then used to update the vocabulary-level lexicon. Our current experiments are based on two datasets. The English-Spanish dataset has languages with similar word ordering, high-quality data. In order to simulate a low-resource domain, we've actually cut the dataset into a smaller size. The English-Tamil dataset has languages with different word ordering and much lower quality data because the data primarily comes from government and religious documents, which uses long sentences and uncommon words often. We also compared the two baselines. The first is an encoder-decoder translation model, like I described at the beginning, which also acts as the backbone to the models that incorporate lexicons. The second is a model that utilizes a statistical lexicon. Due to the time constraints of this project, we do not have final results yet, but we do have some intermediary results to showcase. We test across two splits, one with a full test dataset and one with only sentences containing words seen once in the training data. This data is in terms of BLUE scores, where higher is better and a difference of 1 point is significant. As you can see, our model still lags behind the performance of the statistical lexicon by quite a bit. We predict that this is due to a lack of convergence in our models, a lack of filtration for only confident alignments when training our model, and some architectural faults. We plan to fix these issues in the immediate future. We would also like to, as a more long-term goal, train a version of our model that is jointly trained with the translation network, so it has no reliance on pre-training with gold alignments. We would also like to evaluate on more languages to better understand what typological features lend themselves to benefiting from this technique. Thank you for listening.